gentlemen, we made a start on complex numbers last week, so this is part 2 of that. We're going to do a little drill on what we did last week in a minute, and also a little bit what will lead into some of the stuff that we're going to do this week. But ultimately, this week what I'm going to cover is multiplying polar complex numbers, dividing polar complex numbers, and then the multiplication of rectangular complex numbers. So notice that we're not doing division of rectangular this week. We'll be picking that up next week because that's a little bit more tricky. Okay, so one stage at a time. So that's what we're going to cover this week. What I'd like you to do now is I'm going to write some little quick drill questions on here. We'll just spend about 5 minutes doing this. If you've got someone who weren't here last week next to you, you might like to help them out as to what we're going on with here. Alright, so first of all, number 1. J equals 2. J squared equals J cubed equals number 3. 3 plus 2j plus 4 minus 4 j 4. I want to know the answer to 3 plus 2 times 2 minus 3. Notice there's no j's in that. That's just simple arithmetic. I want to know your answer to that. And that should be, I can't even count, look, that should be 4. 4 comes.
Is that a 2, yeah? 2 minus 3 for question 5.
Where's that? 2 minus 3, yeah. 2. Right neater on the board, Michael. And lastly, little algebra check, that last one. Multiply out the brackets. Yeah, because if we square a square root, we get rid of the square root sign. So j squared must be minus 1. And what does, therefore, j cubed equal? Minus j. Yeah. It's this minus 1 times another j, therefore it must be, it's minus 1 times the square root of minus 1, or minus j. So that's a little bit of a refresher on what j is all about from last week. So how do we add 2 complex numbers together? Real part, imaginary part, real part, imaginary part.
You add the imaginary.
Add the 2 parts separately, yes? So we got 3 plus 4 is 7. 2 plus minus 4. Is it 2 or is it minus 2? 2 plus minus 4 equals minus 2j. Is the correct answer to that one? How do we deal with this? 3 plus 2 in brackets times 2 minus 3 in brackets. Fish method.
Yeah, basically if you draw a line from 3 to 2, and then 3 to minus 3, then 2 plus 2 to 2, and then plus 2 minus 3.
What you're saying is you do that times that, the 3 times minus 3 as well, yeah, and then you do 2 times that. Crab claw method. Well, what method have you used to do that one then?
I've just done 3 plus 2.
It's 5. So let's go with that. Right? And 2 minus 3 is minus 1. So it's 5 times minus 1 equals minus 5. If you use the method this gentleman over here said, what do we end up with? 3 times 2 is 6. 3 times minus 3 is minus 9. 2 times 2 is plus 4. 2 times minus 3 is minus 6. It equals the same. Yep. What these, yeah, and that's nothing. So what the brackets do is force you, because normally, if I write that out, what's the answer to that if I said 3 plus 2 times 2 minus 3? You have to do the multiplication first. So that bit in the middle is 4. 3 plus 4 is 7. Minus 3 is 4. The answer is 4 if you do it that way. So the brackets there force you to do the plus and minus first and then multiply after. So, how do we do this bottom one then? Give me an answer. You give me an answer. Last one.
2a times 3a
Equals 6a
3b times negative 5b.
minus 15b. And that's your answer to that, yeah? Exactly. The method. Yeah. That times that, you've got to do 2 times 3 is 6. A squared.
Yeah, because 2a is
Yeah. And just 2a times minus 5b is minus 15b. Gents, can you settle the noise down a bit, please? 3b times 3a is 9ab. And then the last bit, 3b times minus 5b is... Come on, someone. The last part, plus 3b times minus 5b is... 15b squared.
Minus 15b is minus 10ab.
Yeah, minus 10ab, sorry. And then we can draw, listen, we can draw these two like terms together. So the final answer is 6a squared minus ab minus 15b squared. Everyone agree with that? And you see the method. What we do is we multiply everything in that set of brackets by everything in that set of brackets, write that out in full, and then gather together any like terms. No, it wouldn't affect it, but by convention you don't put the 1, do you? Alright? Okay, so we're going to be using that quite a lot tonight when we do this, the last bit on the multiplication of... So, multiplying polar form complex numbers. So polar form is like this 8 angle 25 degrees, where this is the magnitude and this is the angle. So a polar form complex number. That angle could also be expressed in radians in some cases. So the problem what we're going to look at is multiplying together 8 angle 25 degrees. We're going to multiply that by 4 angle 60 degrees. Okay? How do you think that we might do that? What we do is we multiply those two, multiply the magnitudes, so it equals 8 times 4, angle, and then we add the angles, 25 plus 60. So it's 32 at angle 85 degrees. Second example, 3 angle 16 degrees times 5 angle minus 44 degrees equals 3 times 5 is oh, I beg your pardon. To angle 80. So we've got to go 3 times 5 is 15 times 2 is 30. 16 plus minus 44. 28. Minus 28, isn't it? 16 take away 44. Minus 28 plus 80. Those two added together make minus 28, and then add 80 to it. Got to take 28 off 80, haven't you? 52. Okay. If there are, just as a reminder to you, if there are units involved in a polar complex number, like ohms for instance, so if that was 30 ohms angle, you'd write that like this. No, you're saying that's 30 ohms at angle 52 degrees. So the units go there. That's another thing that's missing quite a lot in your assignment work I marked today. Final answers in the money thing, you don't put the pounds in front of them. Don't miss the units off. And God knows why people are using dollars. I've got no understanding at all when the question was in pounds. Question weren't dollars? Was it? I think out of pounds. I think out of pounds. We'll see. I think that was pounds. Right. What we got on the next page? Right. So, consequently, listen, gentlemen. Dividing two polar numbers, so 16 angle 75 degrees divided by 2 angle 15 degrees. We divide the magnitude of the denominator into the numerator, so we do 16 over 2 angle 75, we subtract the angles, minus 15. So that's 8 angle 60 degrees. Yeah, you do 16 over 2, you divide the denominator magnitude into the numerator magnitude, and then you subtract the denominator angle from the numerator angle. Remember, with subtraction you must get them the right way round. With multiplication, doesn't matter. Okay, this second one has got multiples of pi involved in it. Do we not love that? What does that mean about our angles, do you reckon? Yes, 3.14, come on. Don't cheat by using your calculator. Anyway, listen, please, listen. What does it mean about our angles when we got pi involved?
Positive and negative thing or not.
What is missing from the right-hand question that's included in the left-hand question there? Yeah. As soon as you see pi in the position of an angle, involving any kind of angle, sine function. Gentlemen, will you be quiet, please? As soon as you see pi involving anything to do with angles, to do with sine, cosine functions, that's an angle in radians. Okay? Calculators would then need to go into radian mode if you're doing sine, cosine, tangent functions. Alright? We're not doing that now, I'm just warning you. Okay? So, question B, how would you tackle that? You've got 10 angle pi over 4 times 12 angle pi over 2, all divided by 6 angle pi over 3, minus pi over 3. How would you tackle that? What do you think the best way to tackle that would be? Do it all in one go? Do the numerator first. Okay? So, dealing with the numerator first, what we got to do, 10 times 12, 120, pi over 4 plus pi over 2. Sorry?
Is it pi squared over 6?
Pi squared over 8.
What's that?
Why don't you do that?
Or that, for instance. How do you add fractions together?
That's 2/30, isn't it? That's 1. No. That's a whole.
1, that's 3/3. So how do you do that one? How do you add two fractions together?
Well, you said that a minute ago.
You come and sit at the front next week, then I'll be able to hear you. If you think you're not getting heard, George. Alright? So what's the common denominator then, Harry? It's your idea? 4. So we call that one 2 pi over 4. So what is the final answer? Pi plus 2 pi is 3 pi. No, you don't add them together. That's pi quarters plus 2 pi quarters. Okay? Let's put our denominator back in. How do we finish that off now? How do we finish that off now? Which is angle. So no, we got, yeah, it's 3 pi over 4 minus pi, and that's minus pi over 3. Need to be careful then. What's the common denominator? 12.
Is it 13 pi over 13?
So that's 9 pi over 12 minus, and that's over 12, 4 pi over 12. So that's 13 pi over 12. Yeah? Alright? And the angles there are expressed in radians because pi is involved. How did what become a 4? Pi. Alright? Or not? So if you're not comfortable with that, you need to look up adding and subtracting fractions in your bird book and practice, because you need to be able to do it. Okay? All of you. If you can't do it, you need to practice it. On the next page, there's some examples for you to have a go at for the next little while. I'm going to start feeding you back on some of your assignment work and such.